Hi guys, welcome back. Today we are going to learn one of the most important optimization patterns in programming, which is the sliding window technique. Okay, so let's start with the problem. Okay, given an array, we have an array, okay, and a window size. We are given an array and a window size, which is 3. K is equal to 3. Okay, what we need to do is we need to find the maximum sum of any contiguous subarray, okay, of length or of size k. For example, okay, let's understand the problem here. For example, we need to calculate the sum of three contiguous elements, okay, which has largest sum, maximum sum. Okay, so how we will do this? For example, here, okay, so sum of these first three elements is 1 plus 3 plus 2 is 6. Okay. Then next three elements 3 plus 2 plus 6 is 11. 2 plus 6 minus 1 is 7. Then 6 minus 1 plus 4. Minus 1 plus 4 plus 1. 4 plus 1 plus 8. 1 plus 8 plus 2. Okay. See, we stop here. Okay. We are not going to process these two ones. Okay. Because after this element, starting from here, we do not have three contiguous elements. Okay, so and our task is to find the maximum sum of the contiguous array of length k. Okay, so let's start with a straightforward solution. Okay, so let's do it. So of course, first we need to start a loop here. So let I is equal to 0, I is less than array dot length, but we are not going to process up to array dot length. Okay, we are going to process up to 1 because after that we do not have a three contiguous elements. Okay, so it would be array dot length minus k. Okay, then I plus plus. Okay, yeah, all right. So now we want to calculate the sum, so I will just do let window sum is equal to 0. Let's initialize it. Now we here started a loop, okay, processing each element, but when we are trying to process this element, we need next two elements also, and when we process this one we need next two, and when we process this one we need next two as well. Okay, so here we need another loop here for, okay, now from where we will start this loop? J is equal to I. Okay, I will start with I. Okay, because I need those elements, right? So when I am processing this, I need these three elements. Okay, starting with I. Okay, and J. Sorry, yeah. J is less than up to what? Up to what? When I'm processing this, I need just three elements. I don't want to process these ones when we are processing this one. So J is less than I plus K, then J plus plus. So I just want three elements starting from I plus 3 plus k. Okay, so up to that. Okay, so now let's calculate the window sum here. Window sum would be plus equals to, I'm just putting the sum array of element. Okay, so when we are processing this thing, the inner loop will process these three elements and we will give the window sum. We will have the sum window sum of 6. Okay, so when we reach here we will have window sum of 11. So just like that. Okay, now we have this window sum. Okay, but our task is to find the maximum sum. Okay, so let's create a variable here also. Let max sum is equal to 0. Okay, so when we process the I index, okay, we need to check, we need to assign the window sum to the max sum if window sum is greater than the previous max sum. Okay, so our max sum would be math dot max value between already max sum. Okay, and windows sum. If for the index I, window sum is greater than the max sum, so max sum will be equal to the window sum. So at the end of this loop, what we will have is we will have our max sum. Okay, so we can just print the max sum. Okay, that's it. So let's just run this thing. Okay, here node sliding window. I think okay, yeah, we have not called this normal approach, so let me just, okay, so I'm just going to return the max sum. Okay, and I'm going to do console dot log normal approach. All right, so let's just run it. Yeah, we get the 13. So in this array, 13 is the maximum sum of contiguous elements of size k. So if I look at here, okay, so these are the three elements. So 4 plus 1 plus 8, which has the maximum sum. Okay, so now, so this is the normal approach. We have a loop inside the loop. Okay, so it will work. Okay, we have the answer. Okay, so but now let's think about how we can optimize it. Okay, so how we should optimize it. So now let me just collapse this normal approach. Now let's just think about it here. Okay, so coming back to the array. Okay, so here if we see, let's observe the pattern here. I have given the three examples here. So if I look closely into these examples, what I can see is 3 plus 2 is processed here and 3 plus 2 is processed here. 2 plus 6 is processed here and 2 plus 6 is processed here. Okay, so here we have a repeated things. Okay, so and there is a one thing that is happening here. When calculating this one, what is happening? Okay, these elements are same. Here we are subtracting one element and adding the another one. Again, when we process from here to here, we are subtracting 3, and adding -1. Okay, so same thing for the next element. What will be? We will be doing this for 6, 1 and 4. We will be doing +4 but -2. Okay, so at each step we know, like, we have to subtract one element and add the next element. Okay, so let's try to implement it, you know in a different way, where we will just update the sum instead of recalculating the whole sum. Okay, so let's just implement it. Here we will go with our optimized approach. Perfect. Okay, now let windows sum is equal to 0. At the first step, what I will do, I will calculate this initial sum. Why? Because now we are not going to process each element to recalculate the sum. We will just update the previous sum. Okay, so here I will do the initial loop. Let I is equal to 0, I is less than k, and I plus plus equal to our window size. Okay, so window sum equal to array of I. So we have our window sum here. Okay, all right. So of course we need the maximum also, but here we will initialize the maximum with the window sum first. Okay, so this will be this. Now we saw the pattern, like when we want to process these next array, what we are doing is we are removing one is removing and 6 is entering. So when we do here, 3 is removing, minus 1 is entering. When we do here, 2 is removing, 4 is entering. Okay, so this is the pattern that we observed. Okay, so using that pattern we will just create a loop here. Okay, so let I equals to k, I is less than array dot sorry, length, then I plus plus. Okay, so here we will update the window sum, we will not recalculate it. So window sum equals to window sum minus, when we process this we are leaving one element. So one element is here, array of I minus k, and we are adding one element which is array of the current index. Okay, so here we are updating our window sum. Okay, then same thing, we need to assign this window sum to max sum if this window sum is greater than the previous maximum sum. Okay, so max sum is equal to math dot max, so either max sum or window sum. Okay, yeah, so at the end we will return the max sum. Okay, so let's just print this console dot log optimized approach. See, so for this normal approach as well as for the optimized approach, we get the same answer. 13. 13 is the window. Okay. All right. Okay. So what we did here is, instead of recalculating the sum, we just updated the previous sum. So with this thing, I will do it window sum is equal to old sum. So let's call it new sum. So what will be the new sum we get? It minus leaving element and plus entering element. So this is the logic that we did. We updated the sum by subtracting the leaving element and adding the entering element here. Subtracting the leaving element, adding the this one. Okay. So this will give us the answer. Okay. So what happened here? In the normal approach, our complexity was O n into k. Okay, because first we are processing the loop of n elements, then with the k elements. In the loop has up to k elements. So this was the complexity. Okay. But in the optimized approach, our complexity is just O n, because here we just have one loop. Of course, there are two loops. One is there, but up to k elements we process it here. Okay. And starting from k, we do it in next loop. It's not like loop in a loop. It's a different loop. It's just that first window size elements are used to calculate the initial window sum. Then after starting from the key element, we updating the window sum. So although the complexity is O(n), every element is processed just once. Okay. So this is what is called the sliding window. Okay. This is called the sliding window technique. I hope that you guys understood the approach. Okay. So the important lesson here isn't just, you know, this problem. Okay, like how we will solve, how we solve this problem. It's about recognizing the pattern in the problem. Okay, and use that. Okay, so this video is just all about. Okay, So if you enjoyed this video, subscribe for more optimization and engineering thinking content. So thank you so much. Thank you guys.